Yeah, my name's Kevin Allison. I work with the Marion County Soil and Water Conservation District. My primary job is to help growers learn from growers and just work with growers on soil health and kind of conservation cropping systems. So cover crops and soil testing and nutrient management, mulching, etc. Sean?
Hi, I'm Sean Berthrong. I'm from Butler University. I don't have nearly as good an introduction. I just love soil. I spent my entire life studying it, and I just a kid who dug in the ground when I was a little tiny baby. I just never quite grew up.
Cool. Sean's the guy that I go to when I've got questions. So we're going to leave, I think, a little room for questions at the end, but feel free to raise your hand and ask during the presentation as well. I think that helps us feed off of each other. So I think maybe turn the light on. Yeah, I'm sorry. Yeah, maybe. All right, so I've got a couple types of soils here. They're supposedly from the same soil type, so like pretty similar in geographic location. One has been tilled a lot. The other one has a lot of like porous holes. I'll just kind of walk it around. Yeah. Kind of has a lot of porous holes. It's got aggregates. This is under like a no-till system. That's I think these are taken from corn soybean world, so excuse the relative, but it just to show the concepts that it doesn't really matter the scale. Like for each square foot of soil, like this stuff can work. So I'm going to drop these in this lake test, is what we call this, and you'll see. Try not to shake one of the two up. You kind of see that. Has anybody seen this before? Yeah, it's called a slake test. It's basically kind of a measure of aggregate stability, like the soil to hold itself together. So this is why we get billions of tons of sediment flowing down the White River and flowing down the Wabash. So I've seen tomatoes in like super, in fields with poor soil health just not be able to even hold a tomato plant up. So this is kind of what we're shooting for, right? And there's some chemical stuff going on there. There's some physical stuff going on there, which we'll get into. And then there's a lot of biological stuff that's going on too. So just the aggregation that comes from fungi. We just got out of a talk about balancing, magnesium and calcium. Maybe there's something that to do with this too. But it's soil function, right? It's the soil being able to function. Yeah, you can. Yeah. Thank you, Sean. All right. So I guess to kind of mimic nature, these are the kind of, you may have seen the principles of soil health or just kind of ecology in general, but we're trying to minimize soil disturbance to keep that microorganism in the fungal community alive, keep the soil covered, so keeping it fed, keeping some kind of armor on the soil surface, whether that be a healthy crop, or a healthy cover crop, or mulch, right? Different kinds of mulches. Continuous living roots. As much as I love mulch on the ground and keeping it covered, it's kind of crazy to see the soil underneath like crimson clover in the springtime, whereas instead of having a bare field or just normal mulch, to see this, when you got a tomato crop, it's a root here, and a root there, but when you've got a cover crop on your field, it's just tons of roots in the ground. You've got the photosynthesis happening, you've got the root exudates happening, and just all the mineralization that comes as a part of that. So I look at cover crops as kind of energizing the soil biology and getting it ready for planting, for crop season. And then maximizing plant and biological diversity. That kind of happens no matter what in our vegetable cropping systems, it seems, because we've got so much diverse plants, but to increase that diversity is usually a good thing. So yeah, just a review, minimize disturbance. That's Dr. Eileen Klodifko from Purdue. Those are earthworm channels that she kind of put glue down and then dug up and then chipped away out so she can see kind of the infiltration that's happening, like water infiltration and just, water holding capacity of the soil, keeping it covered. Like I said, the armor. Living roots, that's a picture of kale with an underseeding of oats and radish. So there's a lot of roots in the ground there and a lot of good thing that's happening to soil health and biology. And then just diversifying biology. I think that's sorghum, sudan, and sun hemp. They still got crops going. They got some winter-killed species over here, and back there you've got some more like a different set of cover crops like rye and vetch maybe that are going to live into the spring. So that's all the biology is great, but again, soil testing and like some paying attention to the nutrient management behind it. We're not going to dive too much into this. We're probably going to focus more on organic matter, but you see my organic matter is 3.2. I don't think I'm going to really increase that with cover crops over time. It seems like cover crops are more like a maintenance, and like reducing tillage is more like a maintenance kind of thing for soil or for organic matter. But a shot of compost I think is going to raise that. It's going to raise my cation exchange capacity. So adding inputs like organic matter is super helpful in making this thing tick. And paying attention to pH, of course. So like the biological function seems to be a lot better. You guys have probably seen this slide maybe a few times already in this conference. So, and then kind of, just an example of why we do all that. Again, the keynote speaker hit this hard too, just the network of mycorrhizae fungi that you can get from having a healthy soil, as in comparison to not, as in comparison to something, like you think mycorrhizae are digging this? Nah, probably not.
No pun intended.
Right, probably not. So keeping those things alive and healthy, I think, is key. And some folks say, well, on the small scale and like I get it. It's sometimes hard to get in a cover crop, like if you're in like these urban zones. But if you can, like just the diversity of that action, like compost is awesome, but having diversity. So now you got compost and cover crops, or maybe compost and 3 different kinds of species of cover crops, 3 different kinds of roots in the ground. And I think you start, making that just function better. So yeah, we've seen all the roots. We've seen soil turn from like this with kind of nasty pH zones and like nutrient deficient zones. Like we've seen cover crops and no-till systems push that stuff down and just kind of make it all work better. So that's kind of what we're looking for. It's you can farm all sorts of ways of farming, but like I think I like this example. You got winter killed stuff, and this is the stuff that's going to be the cover crops that are going to be growing in the spring. There's some mulching going on back there, but you see everything's covered. And there's a lot of living stuff out there too. That's kind of the other option. There's in between, right? But you can see that's what's going on here, just the lack of aggregate stability, the ponding that happens because there's crusting, right? You get crusting, and so the roots aren't able to dig in, and when you don't have healthy crops and the roots aren't penetrating, you're not really gaining soil health out of that. So I think the crop is just as important as the cover crop, having health across the board. And then the moisture, I think this is an interesting table. It shows the degree days and then the percent of moisture that's lost. So if you see your soil gets hot, and it can get up to like 107 on bare soils, you start seeing that there's a lot of moisture that's lost. So crop canopy is going to fix that. Mulch is going to certainly help, and I know there's some considerations that people want warmer soils. So when you're managing cover crops and mulching, that's important. To have your soil, let your soil warm up enough. But during the heat of the summer, having a canopy or having cover is going to be huge for plant moisture uptake. So yeah, it's physical, it's chemical, and it's biological. And I think I'll let Sean roll into this.
I give myself 5 minutes before I drop this thing. Hi there. Just out of curiosity, how many of you guys have ever had a soil analysis where you got your organic matter tested? A couple of you guys, right? What were the kind of ranges you guys saw? Remember?
1 to 1.5.
It's pretty low. Yeah, that's right. We're talking about the sandy, pretty sandy soils right there.
Yeah.
So, you guys, anyone else remember roughly where you were? Just kind of 3s? Yeah, 3, 6, 9. Well, that's pretty high. Yeah. So I live right about, well, let's see. No, I'm more on the biological side. But I'm always thinking about how these kind of interactions between the chemical, the physical, and the biological all inform a more healthy soil. So let me just give you a couple things. Probably a bunch of you guys have seen this, but I just want to start with a little bit about what goes into a soil, because these are the factors that build soils over time, and they can build healthier soils. So thinking about where soils come from, what makes them, how you end up with a 1.5 soil organic matter sandy soil, will help you then think about, well, how do I increase that? How do I end up with 9% or 5% and anything in between? And so this is some work from about the turn of the century, a guy named Hans Jenny out in UC Berkeley came up with this kind of paradigm of thinking, what, if you're looking at soil, how did it get there and why does it look like what it does? And he said there's probably about 5 things that really go into defining where soil came from. And the first one is the rocks. What was the original material that gave rise to the material that you're looking at now? Climate, pretty straightforward, right? We have a pretty mesic climate here. We also have fairly cold winters. That's going to influence how quickly that rock breaks down. Driving around Indianapolis, you get a very deep appreciation for what freeze and thaw can do to solid surfaces. But that's very clearly something that's going to influence the kind of soil you have. Is it a hot, dry climate? Is it cold? Is it somewhere in between? Is there a lot of moisture and very little moisture? My favorites, microbes, but also plants, animals. When I say animals, I'm mostly talking about soil animals, so mites, earthworms, nematodes, all those little fun crawlers deep within the soil that influence what kinds of interaction you see in the soil. Topography, obviously, just all of you guys have probably run into issues where if you have a slope, it makes life a little bit more complicated. Before I moved to Indiana, I was in upstate New York, and that's all glacial till. I was in the Finger Lakes region, and it made it very difficult. Fantastic soils, really rich in a lot of nutrients, and a 45-degree angle. Made farming very, very interesting. A lot of the farmers that worked there had really elaborate systems in order to deal with those slopes. Not quite terraced, but they had a lot of stripes, and they thought a lot about how that topography and that elevation and that slope really influenced how they could maintain their soils. And time. That's one we forget about too. Because again, all this I'm telling you this is because, you know, in the end, this isn't just how your soils are now. Think about these kind of influences can influence how your soil will look in a little bit in the future. Again, why? Well, 20,000 years ago, if we were right here, right now, we'd be under, I don't know, 100 feet of ice. So it's a very different kind of time scale to think about. But you can think about where soil comes from historically and use that to build differences in your soil right now. So, a little about soils. So let's see, so you have fairly sandy texture. What other kind of sand textures are you guys working in? Clay, yeah. Fair bits of clays. Straight clay. It's kind of loams. Loam, again, is roughly an equal, well, tilted towards the clay, but an equal mixture of these sand, silts, and clays. I remember years ago when I first learned this, and it still kind of blows my mind. In a healthy soil, so let's see, this guy, which remarkably still hasn't basically slaked at all. This chunk here is about 50% empty space. So there's only about 50% of it is actual solid material. If things are working well, you got about 50% empty space, and that can either be air or water. That's a quote from a couple years ago, the ecstatic skin of the earth, and that's the thing that I always think about that's so exciting about soil. It's not just rock, it's empty space, it's water space, it's living organisms, it's organic material, and all of it works together to make a really, really functional soil. I'm also a microbiologist by training, which is why I love this, because most of the time I'm dealing with petri dishes. Those are not fun. This is fun. This is way more fun because you get all 3 phases of matter, solid, liquid, and gas in the same spot. You can do way more with that in terms of living organisms than you can in basically any other kind of substrate. Mineral. So some of you guys said you're dealing with clay. That's our little tiny aluminosilicate things. Get your sands about 2 millimeters or less, all the way down to 0.5 or 2 millimeters. Liquids, aqueous. Talk a little bit more about that later, because obviously one of the major issues is, does this one have a pointer on it? Do you have a pointer? Oh, there it goes. No, I got it. Liquids being able to get appropriate or ideal infiltration, but also drainage. It's related to whether or not you have good soil structure and an active organic component. Air. Tossed up a fun word there, redox. This is important. This is going to come back later because what I want to do is then lead into a little bit of the biology and think about how, if you have a properly functioning soil, a really uncompacted soil with roughly 50-50 pore space and solid, then you can have a lot of very, very active living microbes. And that matters because if they got a good redox state, basically if they have a fair decent amount of oxygen, they'll be able to chew through organic material and provide soil nutrients and help build even better soil structure over the long term. And let me start with this one. I'm going to pick on the little tiniest component here. So we got about half is solid material. Of that solid material, most of that is mineral. But we've got this little tiny component here in our fully functioning soil, about 5% organic material. And why does it matter? Well, it's pretty small, right? But when I was growing up and I first started trying to talk to my parents about, so what do you want to do with your life? I'm like, I want to be a soil scientist. They're like, really? Yeah. They're philosophers, so they're like philosophers and art historians that looked at me like, you want to study dirt? I'm like, no, I don't. I want to study soil because it's very different. Dirt is really this mineral component just alone. And that's fine. If you want to be a mineralogist, that's a fantastic thing to do. But I was trying to tell them, no, what you've got is you've got a very complex structure. It's mineral, it's empty, there's a little bit of liquid. And the cool thing is it's all bound together by this. The smallest component on that chart, 2, 3, 4, 5, 9%, is really that cornerstone that makes it not just a pile of minerals, but an actual functional soil. So Kevin was mentioning aggregates. It's what holds things together. That's physically what's keeping this, this large, healthy, functioning soil aggregate together. And it's all bound together by, physically bound together by organic material. So this is a false color image here, but fungi here are in this functioning soil have basically worked out through the little crevices and have produced a material called glomalin, which is literally gluing chunks of material together and forming these aggregates that make really, really stable and healthy soils. Oops. Oh, there it goes. So it's literally what binds together dirt, particles of clay, sand, and silt, and turns them into something that's much more functional and much more real. So again, organic matter is literally the glue that turns this into a soil and not just a pile of rocks. And so I'm going to pick on this one a little bit more. So our little friend soil. So organic material here is the smallest component, even in a healthy soil, of our pie chart, but it's really, really, really essential. So we're going to break down that 5%. So I pulled that one little chunk of the pie out, and I'm going to break it down a little bit more because even that is pretty dynamic. It's not just a monolithic entity. Most of you guys have heard about how compost has different carbon-nitrogen ratios. You can get leaves, twigs. You can have finished compost, composted manure. This is why. There's a couple of really distinct components within that organic material. So once it breaks down, once you can't tell that it's a leaf or a twig or animal manure anymore, then it's soil organic material, and then it changes in time. It's really, really important to remember that you have basically pools that are really, really fast in terms of how they turn over and ones that are really, really slow. The fast ones are the ones we call these active pools of organic material. Relatively small, maybe a quarter, maybe a third if you're lucky. These are the things that are pretty recently added material. I'm talking maybe 1, 2, 3 years since you put some composted leaf material on there. Really important, and I'll give you a couple practical examples of what this actually boils down to. This is the stuff that breaks down fast and theoretically supplies a lot of nitrogen and phosphorus from organic material to plants. This is the stuff that maybe can last maybe 10 years before it has to be replenished. Very, very small. Remember, the chunk of that that's actually living is really, really tiny. So 5% of 5% is actual living organisms. We've got the slow stuff here. So I joke about this is basically your checking account in terms of soil management and soil organic material and nutrient availability. This stuff goes pretty quick. A couple years, it's depleted. This chunk here, slightly older organic material. It's a little bit more stabilized. This might last 10, 20, 30 years, and it's a slow releasing, slow breaking down organic material that can continue to supply things like nitrogen, phosphorus, maybe over a couple of years. So that's kind of your savings account. And then you got this stuff here. That's the really old stuff. And I know it can be hard to try and take a decades-long view, but if you can, that's the stuff that basically breaks down the slowest. And that's actually the material, when we talk about the slake test, that's the part that's actually doing the most for the physical structure. So you get organic material, part of it's giving you nitrogen, phosphorus, and then part of it's giving you that structure that keeps your soil together and allows you to get good infiltration, but also potentially good drainage, and stops you from having kind of a muddy kind of mess. Yeah, had a little fun here. Let me pass these guys out. This is one of my passions. It's the microbes that live there. So I'm just going to pass these out for a second here. Let's pass them around for a second. That's about 7 grams. You'll have to forgive me. I'm a scientist, but I'm also Canadian, so I still think in metric most of the time. That's about 7 milliliters or 7 grams of soil. So take those around there and pass them back for a second. And obviously these are dead soils, mostly because I had to dry them out in order to transport them and not have them leak all over the place. But when they were alive, and I pulled these out of the greenhouse at Butler, they were pretty darn functional soils. We had lots of stuff growing in there. I just wanted to give you an example of really kind of how much life is going on in these soils. So there's about 7 grams in there. If you had to take a wild guess, and you can talk about this with your neighbors here for a second, how many bacterial cells do you think, before I dried them out and killed them all off, back when this was a living soil, how many bacteria do you think you might have been able to find in there? Take a second, just come up with like a ballpark number. We're talking hundreds, thousands, billions, billion, trillions, zillions, quadrillion. 100,000s? Anyone else want to be brave? Couple million? Yeah. Oh, that's cheating. You've heard this one before, right? I would say probably, so I intentionally put about 7 grams in there because it's about 1 billion bacterial cells. Let me put that in perspective. And the reason why I use 7 grams, that is literally as many bacteria as there are people alive on Earth right now, in that little chunk right there. So the activity, you can imagine just the activity that's going on and the potential for really incredible biological interactions in just a chunk that small. And I'm not even talking about the nematodes, I'm not talking about the earthworms, the arthropods, the things you can actually see. That's just the bacteria alone. So they're incredible, all over the place. Now, why does that actually matter? Because obviously I've told you there's a ton of bacteria in there. I'm going to give you 2 practical examples, and Kevin's going to talk a little bit about management in between. But one of the key things about it is the combination of having lots of organic material and having tons and tons and tons of living organisms means that you could potentially access a fair bit of nitrogen. And again, the nitrogen, really, really key part. How does it get from organic matter into nitrogen? We'll talk about that in a second, but I just want to give you a little bit of a sense of how much. Because sometimes it can seem like, how could it possibly supply a actually relevant plant or agriculturally relevant amount of nitrogen? So you get two 10%, maybe if you're lucky 10% soil organic material. Of that organic material, of that maybe 5% organic material, only 5% of that is nitrogen. So that means in total, if you're to pick up your soil, you got maybe 0.25% nitrogen, maybe 0.34 if you're lucky. But again, if you integrate that over an acre, so you look at that top 6 inches of soil, that's still about 4,000 pounds, or about 2 tons of nitrogen. So there's a lot of material there you can potentially access. If you manage your soils for soil health, you can use this as a plant available source. All right. So let's talk about it. So we got tons and tons of stuff in there. We got bacteria, we got fungi, we got microarthropods, all sorts of things living in soil. We got mycorrhizal fungus, we got decomposing fungus, we got bacteria, all these little guys living in this soil. What do they actually do for you? So there's a couple practical things. And the first one is nitrogen mineralization. So usually I have a board I can scribble on. That's too bad. That's fine. You guys can follow this part. So let me just give you a little sense of what nitrogen mineralization is. Nitrogen mineralization is the biological process. If you have a nice, healthy, functioning soil with lots of organic material and a lot of living components, you break down your plant material or your compost or your manure, whatever you happen to use as an amendment, breaks down, becomes soil organic material. So basically my rule of thumb is if you can pull something organic out of the ground and can't tell where it came from originally, then it's now officially soil organic matter. Anything else is still just a current amendment. Break it down a little bit. Again, this is their bacteria, your fungi, your nematodes, your earthworms. The key part is that most of the time, just like us, oddly enough, we have a surplus of nitrogen in the food that we take in. That's fine. That's just the way we're physiologically built. Same thing with decomposers. So they actually will spit out a fair bit of ammonia out of this material as they're just eating and chewing through this old dead compost or manure or whatever you happen to add, or, sorry, cover crops. Sorry, Kevin, I forgot. Yeah, cover crops. Yeah, dead cover crops too, absolutely. Remember I told you about redox? Does anyone work in really acid soils? You guys? Oh, okay, how low is the pH in, do you remember? Do you happen to know what the pH in your blueberry? Okay, yeah. So if it's below 5, then typically you'll stop, then the decomposer will stop here. pH and oxygen, if you have a relatively circumneutral, like 6, 7, maybe even a little bit alkaline, 7.2, 7, and as long as you have a pretty non-compacted soil, a lot of this ammonia will get chewed up. These microbes will use oxygen and they'll convert it to nitrate. That's pretty cool, right? Yeah, because then immediately that's right around, oftentimes most active right around the roots of soil. Those tend to be the most active components of soil, and that's really exciting because it goes straight back into the plants. So that's what we call nitrogen mineralization, basically breaking down your organic material, producing ammonium and nitrate. A little balance of that depends again on the texture of your soil, the pH of your soil, the amount of compaction or non-compaction, and that can supply your plants on a fairly substantial basis. That's pretty conceptual, right? Let me give you a little bit of an example of what it actually looks like. Please, 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 don't use this number in your farm calculations. This is a rule of thumb based upon a couple of samples I took from a couple of urban farms around Indianapolis. But you can make an estimate. So again, I told you that in organic material, you got about 2 tons per acre in terms of nitrogen. How much of that actually gets spun off as ammonium and nitrate every year? Because that's a big deal, right? That will inform how much you actually need to amend or maybe cut back your amendments. And if you happen to know a couple things, and you can make a couple of assumptions, the soils that I was working in around here were fairly loamy, pretty maybe clay loamy, a little bit sand loamy, but generally a pretty decent mix of clay, silt, and sand. Obviously, I know a little bit about the climate here. I knew a little bit about the organic matter. That helps a little bit. If you put those together, oh, and also the bulk density. So I happen to know I have a little bulk density sampler, and I knew that the soils here that I was working in were reasonably uncompacted, so they're pretty good shape. I put those together, so I could estimate I knew roughly the percentage of organic material I had. I knew roughly the bulk density. And again, sorry, these are I'll convert them into pounds and acres in a little bit here. I knew roughly the amount of carbon, and I made some estimates based upon the fact that I knew at a loamy soil how fast that material could break down. And so from a couple of straightforward metrics. So if you don't have to measure everything, I measure soil organic matter and I measure nitrogen mineralization in a pretty complex lab situation. And I know that that's not realistic most of the time, but if you've got organic matter and you know roughly your bulk density, if you even just go out there with a penetrometer and get a reasonable sense of how compacted it is, you can make some estimates. I assume that my nitrogen's that about 5% of my organic material, and that about 2.5% of my organic matter decomposes and turns over every year. Again, going to be a lot of variability from soil to soil, but this is a pretty decent starting point if you got a fairly loamy soil somewhere in central Indiana. Sandy clay, if you got clays, going to be a little bit different. Obviously, bulk density is going to be different. You're going to have a kind of basically a heavier soil. If you have a sandy soil, it's going to be slightly different. But this will give you a sense of roughly where kind of a medium textured soil would be. So I had urban soils, relatively not compacted, about 3.5%, maybe 4% organic matter on average in the growing beds. If you plug that into this equation, that'll give you roughly 79 kilograms of nitrogen per hectare per year. I know those make a lot of sense to me, but I know this probably is more what you might run into. That runs into about 70 pounds of nitrogen per acre per year. So that's a pretty useful number to have in the back of your head. Now the big thing is, I said organic matter. Organic matter is super important. How much do you get? I have a 3-year-old, and I'm currently striving for 5 fruits and vegetables. It's a little bit of an uphill battle, but I'm going to apply that metric here. Strive for 5% organic material. Why? Well, you get about, if you switch it over to about 1,000 square feet metric, that means that if you have about 3.5% organic material, a reasonable estimate is about 1.6 pounds of nitrogen per 1,000 square feet. Look what happens though if you can just get it to 5%. You nearly double that to 2.3 pounds of nitrogen produced per 1,000 square feet per year. If you can even get a little higher, maybe get it up to 6%, 6.5%, then you're looking at about 3 pounds of nitrogen produced. Again, not barring any further amendments. This is just stuff that's left over from year to year to year. You can expect maybe 3, 4, or 5 pounds of nitrogen in every 1,000 square foot plot. So that's pretty good.
How much is that per acre, those last two numbers?
Tim, why are you going to make me look these up? I think it gets into about 160, 170 range in pounds per acre. So 100. I remember that when I looked at these numbers, because it's been a while since I looked at them, but it was getting close to the recommendations of 200, 250 pounds of nitrogen per acre that they recommend for row corn. So you're talking about 170, 180 if you have really high functioning soils, really healthy soils, and that's amazing because that is literally close to what you would normally apply if you had row crops. That's a good question. 170, 180 maybe? And so with that, I'm going to pass it back to Kevin. He can tell you how to make some of this organic material.
Anybody got any questions thus far?
So, but you'd have to replenish that every couple of years, though, right? You'd have to add more fresh organic material in order to keep that up?
Well, that's the thing. So remember the
He said he might have turned it
kind
off.
of
Yeah.
chunks of organic material. The slower stuff, the really stable, the really long-term stuff, once that's there, it's 100 to 1,000 years. Some of the other stuff is probably decades, but you are right. The active stuff that turns over, you're turning over about 2.5%, maybe 3% of it a year. So you might have to consider throwing that more of that in, but it's not a huge amount.
Awesome. So I think Sean said not to use those estimates, but I do. So I think like 20 to 30 pounds an acre of nitrogen per percent organic matter, right? So if you have 5% soil organic matter, I'm taking credit for 3 pounds per 1,000 square feet. So if you look at some of the nitrogen requirements of some of the vegetables, like medium total need vegetables, like your lettuces and your melons at 200 pounds an acre, that's 4.6 pounds per 1,000 square feet nitrogen requirement. So I mean, look at the difference. Like if you didn't have soil organic matter, you would be needing to apply all this, right? But if you've got that SOM, and I'm not sure I would take credit for SOM here, right? Or I might tone that down a little bit. But if I know I've got a highly functioning soil, then I might kind of take that gauge up a little bit and maybe do take credit for more of that soil organic matter. So yeah, you've got a less deficit, and maybe that's a reduction in nitrogen fertilizer that you need to put on. Has anybody planted legume cover crops? Yeah. So these things can be pretty powerful too. That's hairy vetch, and other ones crimson clover. There's red clovers, white clovers, but they're known for making nitrogen. They've got an association with nitrogen fixing bacteria in the soil, and that you can put on the seed, and they'll actually kind of create nitrogen and get it into their bodies, and then when they die, it's kind of a slow release back into the soil. So if you take credit for the poundage of nitrogen that comes from this, let's say you take credit for 3 pounds of 1,000 square feet for SOM, and maybe like 1.8 or 2 from the prior legume, you're pretty close to being able to meet those needs for the nitrogen demand for that crop. So really, I mean, that's kind of why a lot of folks through history have used legumes in rotations. That's what that nitrogen fixing bacteria node looks like. In the spring, if you look at them, if they're pink, or I guess even in the fall, if they're pink, that usually means they're functioning better. You can cut it open. I'm not sure if the size matters, but I've seen sun hemp have like these monster nodes, and I've seen hairy vetch just have like tons of nodes that are just kind of packed in these big balls together. But when that plant dies, I just imagine these things just kind of decomposing and kind of leaking out into the soil, and you kind of get this slow release of nitrogen through the rest of the season. It makes a difference when you kill these things. So for example, in the spring, and kind of what cover crop you're using too. Like this is a legume up here, this green bar. So you'll see in the spring, as this cover crop's growing, if you kill it in March, you're not getting much nitrogen out of it. I mean, that hairy vetch or that crimson clover is this big, and it's not really actively making that much nitrogen. So if you're able to wait until May and to terminate it then you're starting to get up there in those plant available nitrogen credits. On the other hand, if you plant like cereal rye, that's where you've got to maybe consider that this cereal rye is maybe tying up a little bit of nitrogen just because it is such a high rich, just a very high carbon crop. So that's where you think on that gauge, okay, I'm taking a little bit of nitrogen away from my cropping system. Maybe I need to put a little bit more like upfront nitrogen on to get that next crop rolling. Or maybe you choose your crop rotation based on this. Let's plant some heavy feeders after legumes, maybe some beans or some peas or things that don't need nitrogen after the rye. Any questions on that? And it kind of, yep.
How would you recommend, like when you say kill, or like what do you just?
Oh, to kill? Yeah. So, yeah, killing cover. Well, yeah, that's a big topic. But I think traditional, like I think you can till in about any cover crop, like in the spring. So I mean, it depends. Like if one of the hard things maybe is a challenge that it's like just the moisture in the spring, you know, like if rye gets, if it's like April and it's like super wet and you can't really get in there with a tractor or your tiller, and then it grows like this in the matter of like 3 days, and then it starts getting a little bit bulky. So there's some considerations on which cover crop to choose and kind of what you're planning to manage. But you know, another way is that whole chop and drop kind of thing, which I really like. And I know it's kind of scale dependent and like management dependent, but I have a lot of luck with like letting hairy vetch flower. I'll chop it down with like a sickle. I think a flail mower would be nice, and then just transplant right into it. Putting a little bit of straw on helps hold it down and stop regrowth. You could put a tarp on for a couple weeks and pull it off to kind of slow regrowth. The canopy, the next crop canopy, helps suppress regrowth as well. And then there's also just maybe choosing a cover crop that just dies. So like the oats and the radishes, those will just kind of die and you don't have to worry about them in the spring. So yeah, this shows carbon and nitrogen kind of ratio. So you can see, you know, this hairy vetch down here is very high nitrogen content, and it's also going to decompose a lot faster. So if you're thinking about like residue, like crop residue in the spring, if you've got one of these low or like high nitrogen plant material, it's going to decompose a lot faster than some of this heavy carbon stuff. So you could maybe use that to your advantage a little bit. I mean, I'm not sure that putting that kind of course of leaves on every crop is going to do well, but maybe peas are the right choice for that, right? So peas make their own nitrogen. They don't really need, you know, much nitrogen inputs. So I think that works. Leaves are probably more of high carbon. I know it's kind of, yeah, depending, like have to do a cost analysis, but like if you can get like kind of clean alfalfa hay, that's got a lot of, it's a legume, right? Alfalfa is a legume. It's got nitrogen in it. As it decomposes, it's going to start leaking out, and that's where like a heavy feeder like broccoli, I think, is going to maybe do well. You can see in terms of cover crops and decomposition, you guys know what this one is? The daikon radishes, right? These are oats. Those are both two cover crops that winter kill. I did some mixing of them this year, which I kind of like, but I heard another person talk, and I kind of agree with him that putting a brassica cover crop in your rotation is maybe a little bit, it kind of complicates crop rotations on specialty crop farms because we plant so many brassicas as crops. And so this is a family. This is in the brassica family, so you're not going to want to do a cover crop radish this year and then a regular radish the next year in that same bed. But its benefits are there. I mean, it sends down this taproot. The earthworms love it. It breaks up compaction. The canopy leafs out real quick, so you can get kind of a head start on crop like cover crop canopy to stop some of those faster germinating weeds. So I really do like it, but I think I like oats just a little bit better. One, they leave more crop residue, which I like, and because it is a little bit maybe higher carbon, this stuff just dissolves in the spring. Like those radishes are, and again, going back to this, if you have a dead cover crop mulch on this, which one's going to decompose it faster? It's this one, right? The healthy soil is going to decompose it faster. So there's a difference there too. I've seen raised beds that are kind of like just sterile, and maybe like in the urban environment where there's no like even connection to like the land base, you could stick mulch on there and it's going to be there for another few years, it seems. So to get biology in those beds is I think is important. So yeah, this is, maybe you ask about how to manage them. This is like oats, maybe draw a little bit of nitrogen away from the system, but if you can plant peas right into that mulch, I think that's like, there's tons of different ways to manage cover crops, but that's just one that I like to use. You could rake those oats off the bed. I guess this is kind of going into cover crop management more, but you could rake the oats off the bed and plant your spring mixes down the beds. But the point is the soil is pretty nice underneath those oats. Like you can rake away the dead oats, or you can incorporate them, or you can leave them on the surface. But the point is that those roots in the ground have increased biology, and they've got food there. They've got habitat. There's apparently mycorrhizae actually love like oat root habitat. So that's why we plant them. It's kind of always focusing not just on yield and things, but just the health of your soil and what it can do for you. Sean?
Let's see if I can make sure not to turn this off again.
I'm not sure I turned it back on. It's fine.
I-
It's fine.
The technology is with me, there's someone else and I'm not working with.
Well, it's blinking green, so I'm going to... Green is good, right?
I hope so.
Green is always good. Anyway, so we're running a little long, but I just wanted to come back to this last thing, because I can tell from some of you guys are talking about sandy soils, fairly heavy soils. Organic material is a good goal in general for any of those kinds of soils, but it depends a little bit on what you want from them. So like Kevin was mentioning that cover crops with legumes, really, really good in terms of adding to that active organic matter fraction. It's going to break down fast, and that's going to spin off a lot of nitrogen. But the other thing is if you're managing maybe for a little bit more long-term structure, so if you have issues with sandy soils and need to develop some aggregates, if you have heavy clays oftentimes can benefit from organic material because then you'll have much more macro aggregate formation, which will improve infiltration and drainage. That's this side here. So if you kind of get long-term management for organic material, that is really about the physical component as opposed to the biological components. This is your kind of long-term organic matter goals here. So this stable fraction, so this is the stuff that's basically broken down, but it hasn't been completely broken off into nitrogen and carbon. If you can hold on to that stuff, that's important because that's what's going to really hold together all of your components. And there's a lot going on here, but I just want to kind of give you a sense that at your biggest, it's about 3 millimeters. So once you start getting into the class of macro aggregates, those are the things that are really what are holding together this soil, that are going to keep you from having drainage issues, that are going to keep you from having massive runoff events and crust formation. That's tied together mostly by things, earthworms, of course, but a lot of it has to do with mycorrhizal and free-living fungus. If you can manage for that as well, those things will hold together and produce a lot of really, really, really strong aggregate structure. How? Over time? Again, remember, you put down something, compost, mulch, you mow in your cover crop. Over time, that breaks down into the stuff called humus, which again is mostly that what we're talking about. We're talking about that stable organic material. That really acts as a glue. So if you look at this, it's just a schematic. If you got clays, what actually holds them together, physically mashes them together and keeps them from turning into just basically kind of a muddy substance, that's usually this organic matter, this stable organic matter. It merges with the clay particles and forms larger scale mineral complexes that will hold together and much, much more effectively under any sort of water stress. So that was the slate test here, but again, if you just look at the difference between a high organic matter and a low organic material versus if you had a low organic material soil without a lot of biological activity, you can see pretty quickly what happens. So if you can increase your organic material over time, you'll get a short-term benefit from basically year to year in terms of nitrogen supply, breaking down and supplying 3, 4, 5, maybe if you're lucky, 6 pounds per acre, per 1,000 square feet. But it has the added benefit if you keep going with it year after year after year, eventually you'll develop these kind of strong aggregate structures that just don't break down as much. So there's pluses and there's benefits to both. Managing it and how much of that organic material you want essentially for this kind of long-term stability versus the kind of shorter term, I say shorter term, but we're still talking 1 year, 2 year, 5, 10-year return. It's going to depend a little bit. You can modulate, like Kevin was showing, that you put in oats or rye straw, that's going to have a lot of carbon, very little nitrogen. You'd say, well, that's not very useful for nitrogen. True. But over time, that'll build that really stable fraction. There's a lot of carbon, not a lot of nitrogen, so it'll tend to produce these stable aggregates that will hold your soil together. If, on the other hand, you think you need to maybe make an investment in a couple of years' worth of getting a lot of nitrogen out of your soil, then you can tilt more towards legumes, If you put those in, if you put in composted manure, whatever you happen to be able to think is the best amendment for your particular field, then you'd be able to get a very short-term return from that organic material and get a lot of nitrogen very quickly. So that's it. We're going to stop there. I know I threw a lot at you, so I'm going to give you guys some time to ask questions about how you can get organic material in there or how it decomposes. So, thank you.
You got thoughts, questions? Yeah.
How does this translate to pasture?
Pasture. Yeah, I think it's kind of amazing how much like sheet erosion can happen on the pasture. Like you don't see it, right? Like you would on a crop field, but I think that you test it, like it's kind of amazing. So I think it does locate, like it does translate. Just having stop grazing heights and like doing rotational grazing. If you're always nubbing the cows are always taking the grass down to this, I mean the roots are just going to be this deep too. But if you've got your grass, you've got stop grazing heights, and your grass is able to really push roots in the ground, like you're not just changing the organic matter or the soil function in that top 2 inches, you're changing the top 6 inches, and that's where water can start flowing in and being held and being cycled correctly. So yeah, it just pushes your better system deeper.
Think about improvements to something that's existing other than, just be more careful in the use of it or adding things to it or?
Just out of curiosity, what is it primarily grasses? Do you have anything that interceded with the? I've seen in upstate New York, people have a lot of success with grazing fields, interspersed grasses with. I don't know what it was.
I have invasive outside clover. Ate the stuff. It's killing the grass.
That is a bummer. So normally I would suggested clover, but you don't want clover.
It's killing the grass.
Oh,
It is
no.
so happy.
Yeah, I'm not a pasture expert, but like I think a grazing specialist might be like, okay, can you intercede into it and like outcompete that? Maybe not. So maybe it's like just push the reset button, try to control the bases, and then just drill and create a new pasture. But I'm not. Yeah.
My irrigation water is from a well with a really high pH. So, and because I have sandy soil, I have to irrigate a lot. So I can see a whole point increase in my pH in 1 year or 2 years. So every other year I have to add sulfur to bring it down. If I add a lot of organic matter to my soil, which is my intention, how will that impact that?
Make
So-
it easier.
Will it stabilize the?
Yeah, especially in sandy soils, especially that stable organic material. It's not just about aggregate formation. It will definitely increase your water holding capacity, your available water capacity, and your overall water holding capacity will decrease almost linearly up to a certain. But you'll get an almost linear increase with every additional percentage of organic material you add in the sandy soil. You'll be able to reduce your irrigation.
Okay.
How quickly that happens depends a lot on your soil conditions. But in general, if you can build that soil organic material, absolutely. That's one of the other major benefits of organic material, especially in coarse soils.
So
CEC and water.
it'll help me stabilize my pH, only because I don't have to irrigate as much.
Yes. And also the decomposition of organic material also tends to lower pH just a little bit as well.
Same question, but for clay soil.
Oh, does organic material, what will that do to pH?
I mean, do you have suggestions for right now? I'm alternating horse manure and chicken manure
And your goal is ultimately to.
and also trying to cover crop as much as possible.
Okay, so you go in your kind of clay soils, what's your ultimate goal, the kind of rate? I'm trying to remember, you're
Yeah,
growing blueberries.
I'm trying to do blueberries, I need to lower the pH, but the field that was hunting was cattle for so long, there was no nutrient value at all, and it was super compacted.
obviously you're putting in high nutrient dense material. Manures are really nitrogen rich. Yeah, sure, adding sulfur on that. I don't know if that's what you wanted to hear, but that would certainly drive down your pH. See the
Well,
one
I'm
is out?
also mounting the blueberries, I'm not planting them into the clay, but I still don't want to bring them because we've got runoff, we've got erosion, we've got all kinds of issues. So.
Yeah, well, certainly, at least for the runoff, structural, the water and structural issues in the soil, increasing the organic material would be helpful. The downside is I see what you mean about having low nutrient availability, which is probably why you're tilting towards the manure. Problem is that tends not to contribute for long-term stable pools of organic material that would kind of help you with the infiltration issues. So if it's possible, and again, it's going to depend on what your relative balance between nutrient supply for your organic material, in case you go towards manure, or if you want to try and build up some of the structural benefits, that's going to be more towards the kind of high carbon nitrogen ratios, like your straws and you want to go really extreme all the way to wood chips and such. But it's going to be hard. Blueberries are hard. Sorry, I couldn't give you a more direct answer than that.
To tie into what she was talking about, I'm trying to prepare soil. We probably have similar soils. I'm trying to prepare soils to put in a food forest in college. And we have access to a lot of wood chips. I'm thinking of, dumping a lot of wood chips, doing some wood chip composting, trying to get the fungal activity up, and hoping that will, in the long term, really help to increase the soil. So I wonder if you have any insight into what that would do in the short term, long term.
Yeah, it would definitely lower the net nitrogen mineralization rates in the short term. Because, obviously, like wood chips, it's all carbon.
Yeah.
All carbon, very little nitrogen, but it would definitely improve the tilth of the physical characteristics over time. If you're at a college, one thing we found out, we have a lot of leaves too. Like we have these giant, just massive piles of leaves that basically the collection that the university piles all in one location. That's actually somewhere in the middle. That has a slightly more nitrogen-rich component to it. Again, it's going to depend a little bit on your nutrient status. If you already have high nitrogen status, relatively high nitrogen availability, then the chips aren't really going to be that much of an issue. They're definitely going to pull your nitrogen mineralization rate down, but if it's already up here, and you need this, it's a big deal.
Especially if we have some areas that probably won't be used for a while. Let it sit for a couple of years. And maybe give it a chance to live.
The perennial plants probably won't be as sensitive to that, right? So
Not necessarily as a forest.
So yeah, maybe like filling in wood chips into a vegetable garden. I think that's as you tie out, but maybe the layer on there, perennial plant.
Would breaking up clay soil prior to you putting on manure or something like that be beneficial or not?
I guess what's your goal? Is the goal kind of to have relatively
The goal is to have less clay in the soil.
Well, we need to roll back a couple of 100,000 years in geological history. Well, to have clays that behave less like clays, I don't know. It depends on how heavy it's gotten and how much the structure is broken down. But if you're probably putting manure, tilling the clay, and then putting, let's say, a compost manure, the compost manure is going to break down pretty quickly. So it probably won't affect the soil physical structure very much. If you're willing to kind of shift to something that will kind of build up the structure over time, so something with a little higher carbon, a little less nitrogen, your straws, your big mulch, whatever, then that would facilitate making more organic material pretty quickly. But I think putting manure down on clay, I don't know if that would really tilling would really be.
Say you opened up with like a pitchfork or a then mix the clay in with that stuff, and then you cover it up with, say, straw or something like that. Was that a benefit, or is that, I'm wasting my time?
It would definitely be a benefit short term in terms of that material breakdown. The composting material will break down pretty quickly and supply you nitrogen pretty rapidly. I don't know if it would kind of break down in the form of a lot of soil humus or stable organic material over time that will kind of make it act a little better in terms of aggregation. So I think the answer is a little bit yes if you just need your short-term formation of active organic material. But if you really want to get to stop acting like a really heavy clay, that's going to be an investment of kind of long-term slower decomposing organic materials, and that would make more sense to till in a little bit.
Okay, so it's at the end of the season, take time to get something to where I would dig up, flip over, and put on, at least in there, grasses or something like that. And then on top, put something on top. That way I can make a sandwich kind of deal. That way it all goes down over the
So
side.
I see what you mean. Yeah, I think that could work. I mean, it would depend a little bit on the rate of water filtration and oxygen filtration. In general.
Oh, it's a sponge.
Oh,
Yeah, I'm not worried about drinking water there. There's always water there.
well, what about have you ever thought about incorporating kind of like the driller kind of dicon rashes too? Because that would also be a pretty effective way to get the organic material a little bit deeper into that soil and start building out more stable organic material over time. So you could do the sandwich, but kind of long term, that would give you kind of the issue where basically the material that you put in now, you create that flip, it's going to decompose pretty quickly. It's going to hit there and it's basically going to evaporate within a year, maybe two, well, depending on how much you put in. Right. So that's the one downside of doing that in turn, because it's going to really evaporate very quickly, which is good for nitrogen supply for the first couple of growing seasons, but it's not going to really contribute at longer term structural advantage to more stable organic material. Yeah. It's tough. I mean, it's going to be depending on whether you kind of want to get some of the more quick advantages for a couple growing seasons, or if you're also going to manage for kind of long-term soil till issues. That's going to be, it might take a little bit more time and a couple of different approaches kind of stacked on each other over the next couple growing seasons.
Okay, so that's all the time we have. So let's thank Sean and Kevin for